IPCC, which stands for Non-Governmental International Panel on Climate Change. Notice the term non-governmental. Get the government out of there, and maybe we'll get some science evaluation done, right? So this was in response, Dr. Singer's response and his group, which include people from all over the world. The guy is very connected, he's networked. He has all sorts of networks of climatologists and scientists throughout the United States, Europe, Australia, and the Far East. And his group put together the response to the IPCC, which I have here, brought one here. Okay. It's called Climate Change Reconsidered. And you go through this and you will get a nice, rational, scientific response to what the IPCC puts out. And for those of you who want to read it, I'll try to get some copies of it. I can't get everybody a copy, but I might be able to get a few copies that can be lent out and you can read it if you want to. Once again, it's a response to the IPCC. So what controls the Earth's temperature? This is kind of some basic stuff that probably a lot of you out there already know this and bear with me here. Basically, the Earth has an energy budget. The temperature is controlled by the energy in and the energy out. Makes sense, right? Very simple. There's some concepts. The energy in comes from the sunlight. There's no other source of energy. The energy out is the amount of radiation back into space. Okay? Now the sum of those two is equal to the energy budget, which will maintain the temperature of the Earth at any given point in time. The energy of the Earth is in equilibrium, so that the energy that comes in and the energy that goes out is some kind of equilibrium, and we have a temperature. It's sort of like a pot of water boiling on a stove. You turn the heat up, the water gets warm, and the temperature goes up, and then it equilibrates. It stays at a certain temperature. If you increase the heat by turning up the stove, the water temperature goes up a little bit more, and then it stops and it achieves an equilibrium. Because the heat coming in is offset by heat going up. You dissipate it in the form of steam. Okay? The Earth is the same way. So we're always in equilibrium. Now what happens if we can change that equilibrium? We can increase the force of the sun, and it's going to keep the Earth up, things being held equal. Or we can play around with the energy that comes out. If we reduce the amount of radiation back into space, that's going to do what? It's going to make the temperature of the Earth go up, assuming that the sun doesn't change. Or we can mess around with both of these, and it will be the algebraic sum of those two will determine the equilibrium or the temperature of the Earth. So with global warming, what's happening is we're going to be messing around with the amount of radiation that leaks back out into space. So what are greenhouse gases? What is the greenhouse effect? Well, very simply, the sunlight that warms the Earth comes down and it heats up the Earth. Okay, we all know that. And when the Earth heats up, objects on the Earth get warm. When they get warm, they give off radiation, long wave heat radiation that goes back up into space. Okay? It's a lower frequency, longer wave. And what happens is the long wave radiation goes up, some of it goes back out into space to cool the Earth, and some of it doesn't. Some of it is trapped by gases in our atmosphere. Because we do have gases in our atmosphere, they can interact with that heat that is brought back up from the surface of the Earth. And some molecules that are called heat-trapping gases or greenhouse gases, carbon dioxide, water, or a couple of good ones, methane, perfluorocarbons are also greenhouse heat-trapping gases. What happens is when that radiation goes up, it interacts with those molecules and they start to vibrate. And when they vibrate, they pick up that extra energy. And like most gas molecules or any other molecules, when they get excited, what they want to do is they want to return to their previous energy state. Okay, that's the most stable form for them. When they do that, when these gas molecules are vibrating, these CO2 molecules, they return to their energy state and they have to give off that extra energy. When they give it off, they radiate it in all directions. Some of those gas molecules are radiating that extra energy back out into space, and some of them will radiate back down into Earth. So that radiated energy that goes back down to Earth is there for when you heat the Earth up again. And so this back radiated heat can undergo another cycle, goes up, bounces back down, up and down. So you have primary, secondary, tertiary effects of heat trapping and re-radiation. And that, in fact, is a greenhouse effect, and it does occur. And it's dependent on certain types of greenhouse effects. Well, this causes it's caused by the atmosphere, and it warms the Earth. It buffers the temperatures. We certainly know that temperatures on a cold night are maintained a lot warmer when we have a cloud cover, right? That's a greenhouse effect. It prevents the long wave radiation from leaking out into space. And it makes the Earth inhabitable. It's a good thing. What are the greenhouse gases in the atmosphere? Well, if you haven't heard of this one, water vapor represents 95% of all the greenhouse gases. It's a very strong greenhouse gas, and it's 95%. CO2, which everybody is all concerned about, is only 3.6%. Nitrous oxide that comes out of automobiles, less than 1%. Methane from garbage dumps and others, less than 1%. So a very small amount, 3% of the greenhouse gas effects are attributable to carbon dioxide. Now, out of the 3.6% of the carbon dioxide that makes up the greenhouse gases, only 3.2% of that is man-made, right? Not all the carbon dioxide in the atmosphere comes from man. Some of it comes from natural sources that we don't really understand. It comes from the oceans, it comes from decaying vegetation, right? We have a lot of plants that die, and the bacteria eat those plants and they want carbon dioxide, a lot of it. So if you think about it, you've only got 3.6% of the greenhouse gas in the atmosphere is carbon dioxide. Out of that, only 3.2% is man-made. Multiply the two together, and you get 0.12% now is attributable of the greenhouse gases in the atmosphere. Only 1.12% is man-made. Now, if you walk away from this talk with any number, that might be it, because that says a lot. It's a small number. Another way to look at it, of course, is you can say that 99.88% of the greenhouse effect is not attributable to man. Okay? So we've got people being worked up here over a very small number. So what does that say intuitively before we go any further? They must be saying that that small amount of greenhouse gas must be very, very powerful if it's going to have some effect, right? By the way, if we look at the increase in CO2 over time, for example, the pre-industrial, pre-industrial CO2 levels were 288 parts per million, and it went up to 368 today. That's a 28% increase over the last 150 years. Out of that, only 14.8% is anthropogenic, which is caused by man. So all of this greenhouse gases, all the CO2 that's been going up over time, since the time of industrialization. A lot of people have been attributed it all to industrialization, but only in fact 14.8% of that is attributable to man. The rest of it are natural increases. So what happens? The system is not so simple. We have to talk about feedbacks. And we can do this really briefly. If we have CO2 in the atmosphere, we know it's a greenhouse gas. It's going to cause global warming. This is a fact. We can do experiments in the lab, put a tube with carbon dioxide in it, shine some light on it, and the temperature will go up. We know that. Okay? But the Earth is a complicated system, and it has what are called feedbacks. And here's the simple feedback. Here's what's called a positive feedback. If we have some CO2 that causes some global warming, okay, we know that's going to happen. Maybe a small amount of global warming, maybe good, but that global warming is going to cause water to evaporate, right? The water vapor is going to go up, and I just got done telling you that water vapor is a greenhouse gas, right? So that greenhouse gas now, that water vapor, further heats the Earth, and that heating further causes more water vapor, back and forth, and you get a positive feedback loop. This is also called a vicious cycle, all right? This is one type of feedback loop that can exist and does exist in the climate. Here's another feedback loop called a negative feedback loop. The same amount of carbon dioxide, or any kind of heating, any kind of radiant forcing, can cause some amount of global warming that causes water vapor to form. This time the water vapor doesn't stay in the form of vapor, it goes up and it cools and it condenses and it forms clouds. Okay? Now cloud cover vapor is a lot different than non-cloud cover vapor, because cloud cover vapor acts as an albedo effect, which means that it reflects this white and it reflects solar energy coming down. And it reflects that solar energy back out into space. And that in fact cools the planet. So when we have water vapor that forms clouds, especially clouds in the lower troposphere or lower atmosphere, we have a negative feedback.